Hi, Mr. Balogh here. Let's tackle this example problem here of these three charges. And what we want to do is we want to find the net force that is on charge number 3 because of charges 1 and 2. Now, in the book, there is a sample problem that does something very similar, slightly different arrangement of the charges, but the same idea. So you can look at that for the method that the book employs. I'm going to use the new r vector method that I referenced in the last video on Coulomb's law to do this problem. I'm doing this for multiple of reasons. Number one, I use it all the time, so you're going to see me use it. You need to be familiar with it. Number two, this is a method that is used by a lot of physicists. And so you might be online looking for information to help you study for your lectures and stuff, and you'll see this method employed. I want you to be familiar with it. And number three, I know what's coming up in this class, and we're going to be using this a lot. Your book will start using it. And so I want you to see it now. I want you to get your first taste of it now. You may choose not to use it for this chapter. That's fine. But you can go ahead and at least been exposed to it so that when it hits you the second time, it isn't as brutal. We want to, again, find the net force on charge number 3. I can go in here right now and I can kind of draw some forces. So for example, charge 1 on charge 3. Well, they're both positive, so that means charge 1 is going to have a force going that way. But charge 2 and charge 3, well, they're opposites in their charges. You can see the data, right? The numbers for everything right here. They're opposite in their charges, and so the force is going to be pointing backwards. Your book then uses what I like to call the force vector method. If you remember anything about Newton's laws, chapters 5 and 6, or in static equilibrium, chapter 11 from physics 4a, where we had to break forces into components and add them all together, that's that method. You can go back and review that or look at how the book is doing a similar problem to this one. They'll break it up into components. The force that's sitting out here, they'll break up into components and just add those components together. We're going to do exactly the same thing, only we're going to do it using the power of this r vector. So we can write down Coulomb's law, right? As KQ1, Q2 all over R cubed R vector instead of having it written down as R hat. And in using the R vector method, your starting point is to start and identify what R vector is for each of these charges. We're going to use the superposition principle, which means that we can ignore charge 2 and just look at charge 1 and charge 3, figure out what that force is, and then we can do the same thing. We can ignore charge 1 and just look at these two, and then we can add those together. If we were to write that down in vector speak, in math speak, right, we're going to find the net force on charge 3, okay, by taking the sum of the force on 3 because of charge 1 plus the force on 3 because of charge 2. This is your book's notation. I've seen other books flip those subscripts, flip their order. So just make sure that if you're looking at stuff online or in other books, that you understand what their notation in the subscripts is doing. So we're going to let's find F31 first, right? F31, this vector, okay? Well, that's going to be K, the electric force constant, charge of 3, charge of 1, all over the distance, right, between 1 and 3, which we're going to find. Oops, I see I did it backwards. I learned it backwards in college, so I'll get that wrong. And that's cubed. And then it's going to be the R31 vector. So the first question we want to answer is, what is R31? And remember, I told you in the last video, R vector starts on the thing causing the force and ends on the thing experiencing the force. In our case, it's going to be from Q1 up to Q3. That's going to be their R vector, R31 vector. So I'm just going to draw that vector right now. Okay, this is R31 vector. It starts on the thing causing the force. It ends on the thing experiencing the force. And I can actually write down what this vector is right now. Our 3, 1 vector consists of two parts. There's a part that points horizontal, and there's a part that points vertical. Okay. The horizontal magnitude is A and points in the positive I hat direction. The y component has length A and points in the positive y direction. I've just looked at my diagram, right? Realized that these lengths are the same, these lengths are the same, it's all square right here. And I can simply just write down what the R31 vector is in unit vector notation. All right, having done that, I can now find the length of R31, right? And I find the length by taking the square root of the x component plus the y component. And it should come as no surprise that this is a times the square root of 2. In other words, this is a 45, right triangles. It's a square, all the angles are 45 degrees. And so if you remember anything about your, trig class, this is 1, 1, square root of 2 relationship right there. And so it should come as no surprise, right, that it should be the length of the side times the square root of 2. We're not always going to have squares. We're not always going to have rectangles, right? We're going to have circles and all kinds of things. And so having a method to be able to just kind of read it right off of a diagram and quickly write it down and be able to calculate its magnitude is going to save you in the end. So we've got the magnitude of R31 vector. We know what R31 vector is. And so I can go ahead and just write down what F, the force 3, 1 vector is. It's K, Q1, Q2, all over A times the square root of 2 cubed times A I hat plus A J hat. And there it is. There's F31. Now I can do exactly the same thing with F32, right? I write it down. It's Q3, Q2 over R32. You should feel free, of course, to pause this video at any time because I know I'm going fast, but you have a pause button, right? We're not in class together, so you can just pause me whenever you want. R32 vector. Again, I identify what the R32 vector is. Well, it starts on the thing that's causing it and ends on the thing that experiences it. So it's going to point along the positive x-axis, which means that I can write this down. It has length A and positive I hat. And I know for some of you that's going to feel wrong. You're like, well, Mr. Balogh, you drew the force pointing the other way. The force points the other way because the charge is negative. We'll handle that. The math will take care of that for us, right? We want to obey what the definition of R vector, which is start on the thing that's causing it, end on the thing that's experiencing it. I've done that, right? It points in the positive, it points along in the positive I hat direction and has length A. So its length is just A, right? And so now I can write down F32 vector. Okay, Q3, Q2 over R, all over A cubed, right? That's the length. I just stuck that right, stuck that right in there, times R32 vector, which is A I hat. And here I have F32. Now, if I want to know what the net force is, I'm going to take F31 and I'm going to add it to F32. Now, I will be doing that in the next video.